So today we're going to cover three other types of tissues. We started by looking at epithelial, bless you.
Thank you.
All right, and today we're going to continue on by considering types of connective tissues and types of muscle tissues. Okay? Now, if you have a system of elimination, it's going to help you narrow down a particular slide or tissue that you're looking at. And the key to narrowing things down will be how do you eliminate something that the tissue that you're looking at is not. Okay, so we're going to kind of use that approach. And key thing will be to look at what to compare. Okay, if you hit that switch on the left. Thanks. All right, notice the system that we're going to use to zero in on the type of tissue that we're looking at. All right. Of course, this is epithelial tissues. So how is it that we're going to not confuse epithelial tissues with the other tissues that we're looking at, especially connective tissues? All right. We're going to note that since epithelial tissue covers and lines all body cavities, outside as well as inside the plane of the body, that will tell us that, okay, if I see a clear space, if this tissue is near a clear space, then it's most likely epithelial tissues. Then you start zeroing in on the different types of epithelial tissues. Okay? Another identifying feature of epithelial tissues is that between the free space, there will be a kind of imaginary border or an imaginary line that follows its own contours. All right? And this will be a line of demarcation called the basement membrane. And it's not so much going to be a clear-cut line, but it's going to be a change of one type of tissue that stains one way and has certain characteristics in common from another type of tissue that looks different. All right? And so when you see this happen and the free space is on one side, and then you got this basement membrane on the other side, that's going to be a second thing that tells you that this must be epithelial, the free space and the basement membrane. Once you know that it's epithelial, then you're going to think, okay, there are two ways to that the various epithelial tissues are named. All right? They are named according to the number of cell layers and according to the shape of the cells. And so once you know that that's epithelium, then those are the two things you're going to look for. Let me point out another distinguishing feature of epithelial cells. And this will be important when you see other kinds of tissues like connective tissues. Epithelial cells will be spaced very close together. Okay? And you won't see very clearly defined cell membranes in all cases. But in the case of epithelial tissues, the shape of the nucleus is what's going to suggest the shape of the overall cell. Okay? And so when we looked at the four shapes of epithelial cells, anybody remember the four types of epithelial cells we looked at before? All right, Joe? Okay, good. Squamous, columnar, cuboidal, and transition. All right? What does the nucleus look like in squamous tissue? As though it's been flattened. Okay? So, for example, these dark staining spots are the nuclei. And you notice how flat they look. Okay? Compare that with these nuclei. You notice how round they look, right? So a round nucleus that's in the center will suggest which of the four shapes of epithelial cells you just mentioned. The round nucleus suggests what? Cuboidal cells, okay? And so, look at how we're approaching this. Okay, so, we know that this is epithelium. How many layers does it look like this tissue has? This is just the epithelium from here to here.
Numerous layers?
How many?
Numerous.
Numerous layers, okay? And so according to the number of layers, how many different kinds of layers could we have? How do we name the tissues according to layers? Stratified.
Simple, pseudo-stratified.
Columnar would be a shape at this point.
Simple.
Stratified and simple,
Pseudo-stratified.
and pseudo-stratified. Okay, falsely stratified. Okay, so let's look at this tissue. Does it look like it's just one cell layer between the basement membrane and the free space?
Yeah.
All right. But what are these things? All of these darkly staining spots. These are the various nuclei of the different cells. So does it look like it's just one layer? If you look at the way that these nuclei are kind of going like this, kind of following the shape of this, contour like that. So does it look like it's just one layer of nuclei?
No.
No, so we can eliminate what?
Simple.
Simple, it's not simple. All right, so it could be stratified, truly stratified, it could be falsely stratified. So in this case, there are just so many nuclei between the basement membrane, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 layers of cells, roughly speaking. So this would be truly stratified. Now, when we have stratified epithelium, the name of the shape of the cell will be based upon the shape of the cells closest to the free space. Okay, so whenever you have stratified tissue, notice that we could have some cuboidal shaped cells, judging by this round nucleus. All right, some kind of flattened cells, but what's going to determine the shape will be the shape of these nuclei closest to the free space. So what kind of shape would this be? Squamous, okay? And so we're sure that this is stratified, we're sure that these are squamous. So the name of this tissue is stratified squamous epithelium.